How we doing, folks? Again, this is literally like 2 minutes after I after I made that first video. It's almost the 10th. It's almost April 10th. Should we wait for it? Oh my gosh! Holy chicken nuggets! Oh, there it goes. Oh, it's April 10th now. Okay. Holy chicken nuggets. That's for you. You guys, you know who you are. Is it weird when I talk right in my microphone? Is it really creepy? I probably think it's really creepy. It's like those people that do those videos where you're like listening to something that's like really soft, and it's really weird. I find those videos really weird. So you probably find this really weird right now. Okay, bye. Okay, so I'm sorry about that. It's midnight. Getting a little loopy. Not like you all folks who like stay up till 4 a.m. playing the video games. So this is section 8.5, day 2. This is the inequalities portion of the lesson. The inequalities portion. I'm going to introduce this by putting it in your calculator, and then we're going to transfer how we did it in our calculator into doing it algebraically. On the test, I'm only going to ask you to do it algebraically because the calculator is like kind of weird. It's like there's like hardly any work to show, and you know you'll have your calculator for the quiz, but I think it's important to understand how to do it algebraically. But to understand the algebra piece of it, you have to know. Well, you'll see. Okay, but shut up, Mr. Lilac. Okay, here we go. All right, so we're going to work with inequalities, right? We're going to work with inequalities. A rational inequality, this is like one of those really stupid definitions. A rational inequality is an inequality with a rational expression in it. Duh. One way to solve a rational inequality is by using graphs and tables. The other way is to do it algebraically. So just like I said, let's take a look and see how this is done. Where did my pen go? There it is. How this is done by using your graphing calculators. So go ahead and get out your graphing calculators. And we're going to put this in as y1, and then we're going to put this in as y2. And we're just going to see what happens. So let me go to my calculator here. Okay. All right, so the first, I've got 8 divided by, I don't know why I put that in parentheses, x plus 1. And then the second in as -2. So what we're really doing here is we're creating a system of equations. We're creating a system of equations where our y1 is a rational function, 8 over x plus 1, and then the y2 is just a horizontal line, -2. Okay, so let's hit my y equal, or not y, my graph. So there's our y1, there's my rational expression going across, and there's my y2. Okay, so now when I say I want to find where it's equal to, right? When I say I want to find what it's equal to, what am I doing here? I'm actually looking for that coordinate, right? If I want to find the equality piece of it, I'm looking for that actual coordinate. So I'm looking for the intersection point. I go to second, calculate, and then choice 5 is intersect. Now, I must move my cursor over, see the blinking dot there. I must move that over to where it's on the correct piece of the graph where the intersection point is. Obviously, it's not going to happen on this upper portion. It's only going to happen on the lower portion, or on the left side, I guess I should say. So I need to move my trace all the way over there. I hit enter over there, and then the second curve, obviously it's just my horizontal line. I can hit it wherever I want, I guess somewhere to where I think it's going to be, and boom. Okay, so where does it happen? It happens at -5. Okay, so I think you can see when it's an equality, man, that's not too bad. Now, and algebraically, this wouldn't be too bad either. I multiply by x plus 1, I get 8 is equal to, -2 x plus 1. And then I say 8 is equal to -2x minus 2. So add the 2, 10 is equal to -2x. Divided by -2 is -5, right? Boom, done, right? So is it equally as easy to do this algebraically as it is by graphing? Yeah, definitely. Okay, so let's talk about inequalities. So we're going to do the exact same process here. We're going to treat this as our y1 and treat this as our y2. Right? So let's go ahead and do that. Let's put that in. Do this with me, folks. We've got an x over an x minus 6. And the y2 is a positive 3. And I go to graph this. Again, this is a rational. And then my linear, my horizontal line, right? Okay, so here's what we have to do. We really have to just analyze this graph, right? I want to know when y1, okay? Now let's make y1 red. When this rational function, and this will continue on over here, right? When this rational function, when the red function is less than or equal to the green. That's a pretty good horizontal line, folks. Right? And that will continue on forever. Okay, so I want to know what the x values are, left and right wise. I want to know left and right wise. When does the y1, when does the rational function go below? When I say below, I mean vertically, up and down, right? Because these are y values, y1 and y2. So I want to know when it's below, vertically below, when the rational is below the linear. Okay, so when does that happen? Obviously, this critical point here, it happens here and then on down, right? Right, because now that rational is below the horizontal line. So every point from looks like, I don't know, 9. Let's actually calculate it. Second, calculate the intersection point. Again, move your cursor. We're going to have to click it a million times here. Got to get the cursor all the way over on that tail of the hyperbola. Hit enter on it. Second curve, hit enter. Guess, enter. 9. Yeah, it does occur at 9. So this is at 9. Okay. So there's my first critical point. Okay. Now, do we all see, though, isn't this entire side underneath that line? Right? Isn't that entire thing underneath that 9? So where does this pick up? Where does this whole piece of the graph pick up? What is this line? Oh, that's our vertical asymptote of this rational function. Where is the vertical asymptote? Well, vertical asymptotes occur where the denominator equals 0. So x equals 6, that's the line. So anywhere 6 and below. Okay, anywhere 6 and below. Can it be 6? No. Okay, it cannot be 6. Even though this is an or equal to symbol, it cannot be 6 because it's an asymptote. It never reaches it at 6. It's only up to 6, getting closer and closer and closer to 6. So my solutions are x is less than 6 or x is greater than or equal to 9. Right? Here's the x is greater than or equal to 9, and then this is all x is less than 6. Why is it an or equal to over here and not here? Because remember, this came from the asymptote, and it can't be equal to the asymptote. This came from my intersection point, and I do want it to be equal to in my intersection point. Okay, let's do one more of those. Oh, no, I lied. Let's do this algebraically. Okay, so why did we do this by our calculator? Okay, well, we have to understand where the critical points lie. The critical points lie where the intersection point is and where any vertical asymptotes occur. That's where things are going to change. Okay, that's where things are going to go above or below each other. So that's what we're going to be doing algebraically when I find these things. Now, in my opinion, solving these algebraically are a little bit more trustworthy. Trustworthy, is that right? Or just, I don't know. You can trust it a little bit more. You have to just use a lot of just thinking about it for this. And sometimes our minds can go in weird directions. So I'd like to think about it algebraically. And heck, the class is algebra, so why not? Okay, so first thing I need to do is find the intersection point. I need to say 6 over x minus 8 is equal to 3 and solve this algebraically. So let's just multiply by x minus 8 over to the other side. 6 is equal to 3 quantity x minus 8. So 6 is equal to 3x minus 24. I could have divided by the 3 first if I wanted to. So 30 is equal to 3x. So 10 is equal to x, right? Okay. So that's one critical point. Where is the other critical point? The vertical asymptote is the other critical point. Where does that happen at? X minus 8 equals 0 is the other critical point. So x equals 8. So here's what we do. We go on a number line and we do that same thing we did when working with quadratics. This is the yes, no, yes, no, yes, no thing, right? We've got 2 critical points, one at 8 and one at 10. And what we're going to do is we're going to pick tested values. We're going to pick a point here, we're going to pick a point here, and we're going to pick a point here and figure out where the solutions lie. So what point could we pick here? Well, I could pick anything below 8. So 0, sure. I could pick anything in between 8 and 9. That's pretty simple. Pick 10, anything between 8 and 10, pick 9. And then I'll pick 11 here. Okay, so let's run this through our function 0. So 6 over 0 minus 8 is negative 8. Is that less than or equal to 3? Well, any negative number is less than or equal to a positive number, so that's a yes. Okay. Now at 9, this would be 6 over 9 minus 8 is 1, is less than or equal to 3. Is that a true statement? No, right? Because 6 is not less than 3. And then pick 11. 6 over 11 minus 8 is 3. Less than or equal to 3. Is that a true statement? Yes. Okay, so what does that mean? That means that any point over here is a solution and any point over here is a solution. But be careful. I know that this is an or equal to. All that means is that this is filled in. This is not filled in. Why is that not filled in? Because of the vertical asymptote, right? It cannot be equal to the asymptote. So x is less than 8 or x is greater than or equal to 10. Okay, let's try another one. Oh, I guess I did this. Okay, so 4 over x minus 3 is greater than or equal to 2. Okay, so first thing I do is find the intersection point, find where it's equal. Okay, so multiply over. 4 is equal to 2, x minus 3. 4 is equal to 2x minus 6. 10 is equal to 2x. So 5 is x. Right? All right, now we find the vertical asymptote. The vertical asymptote is at x equals 3. I'm going to skip the part where I say it's equal to 0. Hopefully we all got that by now. Okay, so my critical points are at 3. I don't know why I wrote it on the bottom at this time. That's okay. And at 5. So let's pick some tested values. 1 here, and 1 here. Let's pick 0 here because that's really easy. 4 here, and 6 there. Those could be whatever you want, right? I'm just picking those numbers out of thin air. Could I choose 4.5 in the middle between 3 and 5? Sure, whatever. Could I pick 10 million in front of 5? Sure, whatever you want to do. Okay, so let's pick 0 and see what happens. 0 is going to get us a 4 over negative 3 is greater than or equal to 2. That's a no, right? That is not a true statement, right? Right. This one was that was a true statement because anything negative is less than or equal to a positive number. This is the opposite. Anything negative is not greater than a positive number. Right? Let's pick a 4. Let's see what happens at 4. 4 over 4 minus 3 is 1. Greater than or equal to 2. Is 4 greater than or equal to 2? Yep. Let's pick a 6. 6. Oh, no. Sorry. 4 over 6 minus 3 is 3. Is that a true statement? 4/3 greater than or equal to 2? No, 1.3 is not greater than 2. So that's a no. Okay, so what happens when we have a no, yes, no? Well, that's an and inequality, remember? Okay, so remember, these are going to point in toward each other. Boop, boop, boop. This is an or equal to, because this is where the intersection point came from. This is an open circle. Why? Because it was the vertical asymptote, and it cannot be equal to a vertical asymptote. So this means I've got 3 is less than x is less than or equal to 5. That's my answer. Okay. All right. Well, I hope we're all having a good day, and I'll see you later, folks.